Hi. So we're actually just going to go through two quick examples for the normal distribution before we go into um, the next topic in the next video. So the quick thing we're going to look at is we're going to try to calculate phi of 0, 1 and phi of 2 infinity. So phi of 0, 1, again, we're going to think about this. So if I look at my curve, right, so if this is my 0 and I have my 1 here, what we're going to do is remember that everything on one side is equal to everything on another side. So this part here is going to be 1/2 of this part here. So phi of 0, 1 is just 1/2 of phi of minus 1, 1. And this we talked about last time is just 68%. So it's 1/2 of 0.68, which is just 0.34, so 34%. So that's it. Nice and easy. How about 2 to infinity? So let's look at this again through the same process. So this is what I always do when I'm thinking about something like this. I say, okay, so here's my curve. I put my 0 in the middle. I want to calculate my 2. So here's my 1 somewhere here. My 2 is going to be somewhere here. So I'll put a bottom graph here. So I'm going to look at here, and I want to go from 2 to infinity. So I want this area here. Well, this area is the same as this area here, right? So this is minus 2. So phi of 2 infinity is equal to phi of minus 2. Phi of minus 2 we already saw, right? This is just 1 minus, yeah. Oh, no, I wanted this slightly different. So this is, again, this is half of these two regions, right? So what we're going to do is we're going to say 1/2 of this region here. Or, sorry, 1/2 of, yeah. So it's 1/2 of this, which is this part, the black part, is the opposite of this part. So we actually have 1/2 of 1 minus phi of minus 2, 2. That's what I want to do. So a lot of this is just manipulation to try to figure out what to do. So if I have this again I have from before, I know exactly what minus 2, 2 is. So I have 1/2, 1 minus 0.95. So it's 1/2 of 0.05, which is 0.025. Right, so 2.5%. So yeah, so a lot of this is really just trying to figure out what's the best way. Another way to kind of do this is actually just look it up in the book, right? So since I have 2 to the infinity here, what you can do is, okay, so say I have this, I have phi of 2 infinity, kind of what I was doing before. This is just equal to phi of minus 2. This is just 1 minus phi of 2. So you can go in the back of the book and kind of see what minus 2 is equal to, or phi of 2 is equal to, and you'll realize this is just equal to 0.975. 0. And from here you would get that, well, if I do this subtraction, I would get 0.025, just as before. So there's multiple ways to kind of look at this and get this information from. So it's kind of dependent on how your brain is working, how your brain is thinking that day, and what you can do. But generally what I always do is I draw these out to kind of help me figure things out. So yeah, so notice how these are also the standard versions. One of the big things is, standard versions. A lot of times these aren't ones, these aren't necessarily mu's or something. So you have to also remember that a lot of times when we're looking at these phis, we're going to be using this formula for the probability for a normal distribution, not a standard normal distribution. For normal distribution, we have to incorporate this mu and this sigma. And this will be done more in the exercises and the homeworks, etc. So we saw this less in these examples. But just note that you want to always consider this minus sign for the expected value divided by the standard deviation in order to accurately compensate for this. So just as a heads up. And that's the example for today, for this video. We'll keep going in the next video on the next topic, which is normal approximation to the binomial distribution. So I will see you all then.